As and lastly, we bring you the B flat blue. The woozy woozy bluesy woozy woozy blue.
Hey guys, Henry here, and today I'll be introducing a new tutorial series for Calculus BC. The series will follow the College Board's Advanced Placement curriculum and how to earn a perfect 5 on the AP exam.
Hold up. Before we begin the definition of calculus, we need to talk about what AP is. AP stands for Advanced Placement, and it simply allows you to get college credits from high school classes. While the college class can cost upwards of thousands of dollars, your AP class will only cost you around $90. I know $90 is still a lot, but it's still way better than college tuition. With your AP credit, you can essentially skip classes, saving you a lot of student debt. You will get your credits depending on a test in May. This test is what the $90 are for, and it's administered by the same guys who did your SAT, the College Board. The exam is split usually into two sections: multiple choice, calculator multiple choice for math, and free response. Free response, aka FRQs, are simply short answer questions with 3 to 5 parts. You are scored on a scale of 1 to 5, with 1 meaning that you literally just put your name on it, and 5 meaning you really know yourself. The scale varies year to year since it's based on a bell curve, but the majority of people will always get a 3. You just have to beat the majority to get a 5. What's more important is that different colleges accept different AP scores. Some, like Virginia Tech, for instance, will accept scores as low as 3 for Calc BC, but other schools like Cornell will only accept 4s or 5s. Generally speaking, 5s are your target, but it's okay to get a 4. 3s are less preferable, but many colleges still accept them. 2s and 1s are just fail scores. You won't be getting any college credits from those. Also, College Board this year, as of 2019, wants your money early. So you're going to have to make an upfront payment to them by November 1st, and this is a $40 upfront, and it's non-refundable. Later on, you will have to pay the rest of the $50 in January and February. College Board says that this is because they want people to keep their AP classes and not drop them, but, whatever.
Now, back to Calc BC. Let's talk about what calculus is. We know that algebra is the math of relationships, or the math of the unknown. It's all about seeing the relationship between two variables. Here we have x and y. This is a relationship of 3 between x and y, as seen here. Y equals 3x. For every one interval of x, we jump 3 intervals of y. We can use this relationship knowledge to find unknowns. Say we don't know what x is, but we do know what y is. We can plug our known y into the linear relationship to predict what x will be at a certain point, this point being y equals 5. We also know that geometry is the math of shapes. A volume of a cylinder is 2 pi, radius times the height. Diagonal of a square is square root 2 times the side. A cone is 1/3 the area of a cylinder. A formula sheet with most of the geometry you will need to know will be in the description. Well, calculus is the math of change. It is where we take all of the algebra and all of the geometry that we've ever learned and applied it to the real world. Everything in algebra and geometry has a flaw. They're theoretical. Farmer Bob may technically have 3 piles of hay left for his horses tomorrow after feeding 9 to the sheep and 4 to the pigs. But he's not realistically factoring in the rate of spoilage or the change in the animal's appetite. Algebra and geometry need help in the real world from calculus because their math doesn't account much for change. Everything in the real world changes, so math must too. Basic calculus is split into 3 sections: A, B, and C. A is essentially pre-calc. Many teachers for Calc AB even skip this since it's basically in trigonometry and Algebra 2. You should know sine, cosine, tan, and all of their funny rules. You should also be very familiar with relationships between x and y and how their graphs work and look. B is the holy trinity of calculus: limits, derivatives, and antiderivatives. They're probably the most important subject in most calculus classes. Limits are an extension to the relationships you saw in algebra. Instead of finding out what happens exactly to y at a certain x, you are finding out what would happen to y as x approaches a certain value. As seen here, the limit as x approaches this value c, what would happen to y? Derivatives are essentially functions of the slope. They take a mathematical relationship and they tell you how it changes over time. For example, take this y equals x minus 3 to the power of 2 plus 1 curve. When I take the derivative of this function, I get y prime equals 2 times x minus 3. Later on, we'll get to how to derive, but for now, just accept that this second function is the derivative of this first function. When I graph both of them onto coordinate planes, you will see that at the same x's, the first curve will reach its minimum, and the second line will reach its crossing point between negative and positive. So essentially, at this x value c, the line will cross from negative y values to positive y values. Notice how this is exactly replicated onto the first function, where the slope is negative, so the function is decreasing, and at the same x value c, it changes to increasing. So essentially, at every x value, the second function will tell you the slope of the first function.
Present Henry here. I know that past Henry defined derivatives as functions of the slope, but in reality, they're more functions of the rate. Rate is essentially a value over time, just like how slope is y over x. In algebra, we always had x as the horizontal axis and y as the vertical axis. But in calculus, most of the time, the horizontal axis will become time, and the vertical axis will become a value axis. So essentially, the rate will equal slope, but think of rate more as a realistic implementation of slope, and slope a more mathematical representation of rate. If you don't understand now, we'll get to it later, the difference between slope and rate, but just remember that for our purposes, slope and rate are very similar.
Now the final part of the trinity are antiderivatives. Antiderivatives are the exact opposite of derivatives, in which I don't know the first function, but I do know the second function. So essentially, I take the second function, plug it into an antiderivative, and I will get the first function. So the antiderivative of 2 times x minus 3 will give me x minus 3 to the power of 2 plus 1. Calculus C is the last part of the basic curriculum. It essentially takes all of the skills that you know from limits, derivatives, and antiderivatives and applies them into more complex cases, such as improper integrals or L'Hopital's rule. It also has another section called infinite series, where it essentially expands on the series that you learned in algebra, where you take a pattern of many, many numbers and you add them all together or multiply them all together. This is an example of a Maclaurin expansion of sine x, but this is much farther later on the year, and we'll get to that eventually. This series will be focusing primarily on B and C, with a small assumption that you are at least a little familiar with the concepts in B. We won't be doing much of A because those concepts have already been drilled into your brain last year and the year before. However, if any of these concepts seem a little overwhelming, don't be worried. In the coming episodes, we'll be going much more in-depth than what I've done in this introduction. And this episode only serves just to tell you the scope of the topics that we will be discussing. In the next 2 episodes, I think, I'll be doing a recap on limits and all the rules you should know for around 20% of the AP test in May. Thanks for watching.